Hi everyone. I wanted to walk you through the steps to graph these functions on your graphing calculator. So let's look at our first equation, y equals x squared plus 2. I'm going to go over to my calculator, so you want to turn your calculator on. And first I'm going to have you press the y equals key, which is up here. And remember, on my calculator screen, the last button that I push is going to show up in red. And so you can follow along that way. And you'll see that I actually already have the function plugged in, but I'm going to clear it so that I can show you how I got this to be typed in this way. And if you have anything in your y equals, if you have one of those regression lines in there that we stored in from last week, just press clear. And if you have anything in any of your others, y2, y3, y4, you can just use the down arrow. Press clear on each one of those to get it all cleared out. All right, to type in x squared, so we're going to press this key right here. Notice that there's an x in front. There's also a few other variables, but we're going to start with x. And then to get our squared, we're going to press this key down here above log. Actually looks like x squared, so that's going to square whatever we just typed in. And then we're just going to go ahead and add 2 on the end, so we'll write our plus 2. All right, now to view this on our graph, I'm going to have you go to your window. We're going to check to see if we need to change any window settings. And this is a really nice standard window setting here, -10 to 10 in both directions. You might have a different window setting from when we did our scatter plots last week, and so we might need to actually type these in. You can type over numbers. You can press clear to clear it out and start over. One tip I will give you when you're doing the -10 is make sure that you're using the negative sign. So down here below the 3, we don't want to use the subtraction sign. So -10 to 10. In the x direction, let's have our x scale set to 1. That just means that each tick mark on our axis will just be 1 unit. We'll do -10 to 10 also in the y direction. All right, when we're ready to look at our graph, go ahead and hit graph. All right, there is our parabola shape. So we're going to take that, and I'm going to have you draw what you see right here for that first graph. All right, now I want to talk you through how to do the next equation that's going to involve an absolute value. So I want to show you how to do that. So I'm going to go back to my calculator. So we'll go ahead and press y equals and press clear. So we're going to start this over. And to get our absolute value to show up, we are going to press the math key. So it's right here below alpha. So we're going to press math and then arrow over to the number menu, and we're going to choose the first option, ABS, which stands for absolute value. Now, if you have a newer version of the calculator like mine, you might see that it has those absolute value bars right there. Older version, it might just say ABS with the starting parenthesis. It just does the same thing. We're going to put an X in there. So we're going to get our X by pressing that same variable key we did before. And then I am going to use the right arrow to kind of arrow outside of that. And if your calculator says the ABS with the start of your parenthesis, you want to close the parenthesis around it. And you can do that, the parenthesis here above the 9. That'll close that out. And then let's go back to our equation. So then we want to put a -3 at the end. This time we are actually going to use that subtraction key. And we don't need to do anything with our window. You can do a quick check if you want. It should be the same setting as we did for the last one. And we're going to go ahead and take a look at our graph. And then back on your paper, you can draw a sketch of what you saw that time. All right, last one we're going to do, let's look at our third equation here. This one involves the square root of x. So back to my calculator. And go back to y equals. I'm going to clear this out. To get the square root, so remember the squared key that we hit earlier. If you press second before the squared key, that's going to get your square root symbol. So we have our square root. I'm going to put an X in there. Now, it's very important that you do the right arrow to get out of that. So if you don't do that, notice how what do we have on the end of that? It's a +1. So if I were to put +1 and not arrow outside of the square root, it's going to put that +1 inside the square root, which we don't want. So I'm going to actually highlight the 1. I'm going to press the delete key here. Delete's really nice if you just need to get rid of one little piece and you don't want to clear out the whole thing. I'm going to delete also the plus sign. Now I'm going to arrow out. Now notice that when I do the +1, see how it is truly on the outside. So let's go over here and take a look at our graph. And you can see there's been a change there by adding that 1 on the end. And so you're going to go ahead and draw what you see here. So now I want you to continue working through number 2 and 3. So describing what happens to the graph of the parent function when you add or subtract a number on the end. What do you notice in a few sentences? And then without using the calculator, sketch what you think the following graphs will look like based on your observations above. And if you want, you could sketch them and then you could put them in your calculator afterward just to do a quick check. So right now I'm going to have you actually pause this video until you are completely finished with steps 2 and 3. And when you're done with the front side, go ahead and turn your paper over to the back and then you can continue with the video. Okay, for part 2, I'm just going to give you a few tips on typing these into your calculator, and then like before, I will then just have you pause the video so you have a chance to work through the rest of part 2 on this page. So you'll notice that we have a version of a function that's squared, so we're going to see another parabola. We have another one that's absolute value. We have another square root function. But notice how the way the numbers are inserted into these equations looks a little different than the first set that we noticed. So going back to our calculator, we'll go back to our y equals. You can press clear. So to type in that first equation, we're going to just type it in exactly as we see it on the paper there. So you have your parentheses, x plus 2, close the parenthesis, and then you're going to press that squared key to get that squared on the outside. On your own, take a look at the graph and then draw what you see. All right, when you are ready for the next one, we're going to clear this out. So this time we're doing absolute value x minus 3. So remember, to get to absolute value, you're going to press Math, go to the number menu, press enter for absolute value. Now this time inside of our absolute value is x minus 3. And you can arrow to the right to get outside of that. All right, when you've done that, press graph, see what your graph looks like, sketch it on your paper. All right, then when you're ready to graph the third one, so I'm going to clear this. We're going to get that square root by going second, x squared. This time it's x plus 1, and notice how that plus 1 is on the inside. This time we want it on the inside. Go ahead and look at your graph for that one and sketch what you see. All right, so once you've graphed these 3 and you drew what you saw, go ahead and continue with part 2, so answering questions 2 and 3. So go ahead and pause the video so that you can do that. When you're completely finished with this page, go ahead and start the video again, and we'll continue on the next side. All right, for this next set, we are going to be looking at equations, 3 equations graphed on the same set of axes. It's really helpful if you have 3 different colors. However, you could just label each equation so you know which is which, even if you don't have your colors, and that's okay. So I want to show you on the calculator, how we can put in that first set. So we're going to go back into y equals. So press y equals if you need to. Press clear. And so our first one we're going to type in is x squared. And then into y2, we're just going to put a 2 in front, 2x squared. And y3 will have a 3 in front, so we have 3x squared. So when you hit graph, the calculator is going to draw whatever's in y1. It's going to draw that first. going to draw y2 second, and it's going to draw y3 third. So if your calculator is not color-coded the way that mine is, pay attention to the order that the calculator draws them so that when you go back to sketch this on your paper, you can label, you know which is which. So that's how you can do the first set. So I'll let you do that part on your own, graph and draw what you see. And then for the next set, we're looking at some changes with absolute value. So you can pause the video if you need to and jump back on when you are ready for the next set. Okay, so this one has to do with absolute value. So we're going to go to Math, Number, so press Enter for absolute value, and we're just going to put an X inside. So that's our first one. Secondly, we have a 1/2 in front, and then we have a 1/4 in front. So there's a couple of ways you can do this. You could turn it to a decimal. So you could put a 0.5. Put a 0.5 in front like that. Or you could keep it as a fraction. So like for the next one, 1/4, if it is a fraction, let's put that in parentheses, and you're going to type in 1 divided by 4 in parentheses, and that'll be in front of your absolute value sign. And if you wanted to do 0.25 for that decimal, you could. All right, so we got them entered in. Hit graph. Remember that the calculator is going to draw them in order. Y1 is always first, then it'll draw Y2, then it'll draw Y3. So go ahead and draw what you see there and label. So pause the video and jump back on when you're ready. And if you haven't already, go ahead and continue answering questions 2 and 3. Okay, when you're ready for this last section, part 4, we're going to look at a few other sets of 2 equations at the same time using both y1 and y2. The only difference here is that we are going to be sticking a negative sign in front. So let's go back to our calculator. I'm going to clear all of these out. All right, so for our first equation, we've got x squared. So to put your negative in front, you're going to use that negative sign, again, that's below the 3, and that will be your first set. So you can take a look at that graph, draw what you see. When you're ready, do the next set, and do the next one. In the last set, you're going to see what happens if you put a negative on the inside compared to a negative on the outside. So each of those situations, look at the graph, draw what you see, and then answer these 2 questions, number 1 and 2. All right, when you have finished working through the entire exploration part on your own, so parts 1 through 4, I'm going to have you turn your paper over to the next page, and you're going to see the summary of transformations chart. So we have some scenarios described, like adding a number on the end, subtracting a number on the end. So there's an example that's given there for you. On your own, I want you to describe in words how the graph changed for each scenario. How was it different from the original? Think about the original parent graphs that we looked at in class on Tuesday, the library of functions. Think about what does the original x squared look like compared to the change. And so I want you to pause this video and fill out the rest of your chart. When you are finished with that, then I want you to restart the video, and I'm going to go through a summary with you. Okay, so at this time, so if you're restarting the video, you should already have this chart all the way filled in, and let's just go through this together. So adding a number on the end, description of how the graph changes, we should see that our graph moved up a certain number of spaces. In this case, if it's a +4 on the end, our graph is going to move up 4 spaces. Whatever this value is that's added tells us how many units we're moving up. The second scenario, if we're subtracting a number on the end, we should see that our graph has moved down a certain number of spaces. So in this case, it's moving down 1 space. If we're adding a number on the inside, this causes our graph to move left a certain number of spaces. In this case, it would be moves left 2 spaces. Subtracting a number on the inside, our graph is going to move right. Multiplying by a number greater than 1 in front is going to cause our graph to be vertically stretched. So if you think about your graph, if you think about that being made out of maybe a string of silly putty or something, and if you grab the top and bottom and stretch it in the vertical direction, it's going to make it narrower. If it was a parabola, it's going to make it a lot closer to the y-axis. It's going to look skinnier or narrower. Multiplying by a number in front that is less than 1, so a fraction value something like 1/3, we say that this is vertically compressed. This is the opposite of stretched. It's going to make our graph a lot wider, something like that. All right, putting a negative out in front, you may have noticed that it flipped over the x-axis. A mathematical way to say that is that it's reflected over the x-axis. And with a negative on the inside, what you should have noticed is that it reflects over the y-axis. So here's how we can think about these reflections. So flipped over the x-axis, the idea is that if you were to fold your paper over the x-axis, the top part of your paper, wherever that is, it's going to flip over and touch the bottom part. So let's say this is our x-axis, so that's reflected over the x. If it's reflected over the y-axis, and let's say this is our original graph, think about folding your paper in half over that y-axis, and think about where that graph is going to touch the paper on the other side, and that's a reflection over the y-axis. All right, if you turn your paper over to the back side, the final piece that we're going to finish up with is looking at putting transformations together. So sometimes we have more than one thing going on with the same graph. So we have an equation here on the left side. We're going to start by describing the transformation in words. So notice how this one, first thing we notice, we're adding 4 on the inside of our function. So that's going to cause our graph to move to the left 4 spaces. And then because that -2 is on the end, on the outside, this is going to move our graph down 2 spaces. All right, what I like to do with these, so the parent graph for this one, the original graph that these movements are based on, the parent graph is y equals square root x. So what I like to do is actually plot some points on my graph. So we have 0, 0, 1, 1, 4, 2, and I'm going to actually do that with a dotted line, and I'm going to label that the parent graph square root x. Then I'm going to think about moving each one of my points left 4 spaces and down 2. So I'm going to start with the starter point, so it's going to go left 4, down 2. This point, left 4, down 2. This one, when it goes left 4, down 2, there's a little bit of an overlap, but I'm now going to connect this one with a solid line. All right, let's look at what's going on with our next equation. So it looks like we have 3 things going on. So I want you to fill these in. So on your paper, I want you to write, what does the 2 in front do? What does the -3 do on the inside? What does the +1 do on the outside? I want you to pause the video right now, fill these in on your own, and then restart the video when you're ready. All right, so let's go through these. So we should say that 2 in front will cause our graph to be vertically stretched, so it's going to look skinnier or narrower. The -3 on the inside is going to cause our graph to move to the right 3 spaces. The plus 1 on the outside is going to cause our graph to move up 1 space. All right, let's write off to the side here the parent graph, the original graph that these transformations are based on, is y equals x squared. So the original y equals x squared, I'm just going to do that with a dotted line, our basic parabola shape. Okay, so what we like to do for our parabolas is to think about moving our vertex point first. So I'm going to take the vertex, it's going to move to the right 3 spaces and up 1. So I'm going to plot the new vertex right there. Then since it's vertically stretched, it's going to be skinnier or narrower. And so if I make it look narrower, it might be something like that. All right, for this last one, again, we're going to describe the 3 things that are going on. So we have that negative in front, we've got a 1/5 in front, here we have a +2 on the inside. I want you to pause the video, write down on your paper what each thing is going to do, and then restart the video when you're ready. All right, so that negative in front is going to cause this to be reflected over the x-axis. The 1/5 in front, since that's a fraction value, it's going to cause our graph to be vertically compressed. So our shape, it's going to look wider than the original, and then this +2 on the inside is going to cause our graph to move left 2 spaces. The parent graph for this one is the regular absolute value, y equals absolute value of x. I'm going to do that one with a dotted line. So our V shape for absolute value graphs, the original, we've got a slope of 1 on one side, we have a slope of -1 on the other side. Okay, so let's, kind of like we did with our parabola, let's think about our vertex point first. That is going to move to the left 2 spaces. It's going to be flipped over the x-axis, so the V shape is going to be going down like this. And then here's actually what we do with the 1/5. The 1/5 actually gives us an idea about the slope of these 2 straight lines. And so if you think about rise over run, vertical change is 1 space, the horizontal change is 5 spaces. So think about going down 1 and then over 5. In each direction, down 1, over 5. It's going to go a little bit off our graph, but it's going to end up looking something like this. And we can see, yep, that is quite a bit wider than the original. So it's definitely vertically compressed. It's reflected over the x-axis, and our vertex, we moved over left too. All right, so that's a summary of our function transformations. And in this last piece, we've seen how they can all work together. You can use the rest of your time now in class to work on your 2.6 homework, and whatever is not finished in class will need to be done at home because this will be due on Monday. Thank you, guys.